Good morning, class. So today we're going to be learning how to graph rational functions, right? We've already covered how to find the vertical asymptotes, the horizontal asymptotes, and the slant asymptotes, right? Today we're going to be learning how to apply all of that in order to finally graph our first function. Now, this example, I'm not actually going to go into too much detail. I just want to point a few things out. All right. I hope you guys can go through with it on your own time. And instead, I'm going to be dedicating this video to explaining an actual problem from the ones you're going to be solving. But there was something very important that I need you guys to understand. In this part, after we have found the vertical asymptotes, the horizontal asymptotes, and the slant asymptotes, and all the intercepts and whatnots, we arrive to this point right here. All right. Step number 6. Plot points between and beyond each intercept and asymptote. In other words, once we have found all of that, we're going to then strategically choose our points in X in order to find the corresponding points in Y. All right, now I know it doesn't make much sense right now, right off the bat, but just keep it in mind once we're explaining the next problem. All right, just wanted to clear that out. So, let's go straight to the problem that I'm going to be showing you how to solve. I'm going to begin by explaining problem number 71. All right, here we are. Now, the instructions tell us, find the slant asymptote of the graph, and then we have to follow the 7-step strategy, which is what I showed you initially, which again, you can read it on your own time, in order to find to graph the function. Right? So we're going to be graphing this problem right here. Now, I've already prepared most of the solution, but it's not completely done yet. All right. So here we go. Once we have our function, which is x squared minus 1 divided by x, we try to simplify it. We cannot simplify it. So then we begin looking for the asymptotes, right? So because the denominator is only x, then that means that the value where the function doesn't exist is when x is equal to 0. So we have a vertical asymptote when x is equal to 0. All right? That's old news. We've already done that many times, so hopefully no doubts so far. Now, once we have found the vertical asymptote, we look for the horizontal asymptote. Now, remember the 3 rules. If the denominator's exponent is greater, that means we have a horizontal asymptote when y is equal to 0. If both the exponents are the same, we have a horizontal asymptote when we divide the coefficients. And finally, we have, if the numerator's exponent is greater, then that means that there's no horizontal asymptote, right? Which is this case. No horizontal asymptote because the numerator's exponent is greater than the one from the denominator. Which brings us to the slant asymptote. Because our numerator's exponent is exactly 1 greater than the one from the denominator, we have a slant asymptote. And how would we find it? Well, we divide the denominator by the numerator. In this case, we use 0, right? Because that is the number that is being added to the denominator, is x plus 0, which yields us the result that we have, well, I didn't write it here. Let's write it real quick right here. Give me a second. We would have x plus 0 is equal to, minus 1 divided by x. Right? So this will be our equation, which from here we take the horizontal asymptote from this point, right? That is why y is equal to x. All right, so now that we have our asymptotes, we can look for the intercepts, right? Remember, we have both an x-intercept and a y-intercept, hopefully. Now, in order to find the intercept in y, we normally substitute the value of x as 0, right? So we say x is equal to 0, and then we evaluate that in y. But because we have a vertical asymptote where x is equal to 0, we cannot have a y-intercept. There's absolutely no way we can write 0. Remember, if x is equal to 0, the denominator will be 0, and we cannot have that. So we arrive to the conclusion that our y-intercept doesn't exist. All right? Now, for the x-intercept, in order to find that, we say that y must be equal to 0. Right? So in order to find the y-intercept, we say x is equal to 0. And in order to find the x-intercept, in order to find the x-intercept, we say that y is equal to 0. Old news, but just reviewing. So we have our original equation, and we say this must be equal to 0. 0 is equal to x squared minus 1 divided by x. Now we just solve for x. How do we do that? We have to get rid of this denominator, so we do it by multiplying. So x times x, we cancel it out. And whatever we do on the right side, we do on the left side as well. And x times 0 is 0, right? I wrote 0x just so that you know what happened to that x, but it's actually just 0, all right? Then we have that 0x is equal, just 0 is x squared minus 1. And then we just factor it, x minus 1, x plus 1. And then from x plus 1, we have the result that x is negative 1. And from x minus 1, we have that x is equal to 1. So now we have two x-intercepts. All right, hopefully I didn't go too fast there. And now here comes the good part. Now we can graph.